Today we are going to start with a new concept that is related to mass, weight, and density. And this concept is very easy as compared to the uh, previous topics that we discussed about forces and Newton's law. So first of all, we are going to compare mass and weight. So let's differentiate what is the clear difference between mass and weight, how to differentiate mass and weight, what are the other differences in the concept of mass and weight. First of all, if we talk about the mass, so mass can be defined as the amount or the quantity of a matter present in a body. For example, if we consider a human body, if we consider our body, so we know that in our body there are different organs, bones, tissue, cell, etc. that are making up a whole mass of our body. So in the same way, if you consider any solid block, so that solid block is made up of atoms and molecules definitely. So the total quantity of the matter, whatever the type of matter we are using over there, so that is called the concept of the mass. So it is the amount of matter present in a body. And if we talk about the weight of a body, so weight means it is the effect of gravitational field on mass. So this is the basic difference between the mass and the weight concept, because weight depends upon the gravitational force, just like we discussed in the free fall motion also, that gravity pulls the object towards itself, like towards the earth's surface. And the second difference is the SI unit of mass is kg. Kilogram kg. And for the weight we use the SI unit of Newton, just like the force. And another difference between mass and weight, if you remember the concept of scalar and vector quantity, so mass is a scalar quantity.
Assalamu alaikum, sir.
Walaikum assalam.
How are you, sir?
Alhamdulillah. Okay, mass is a scalar quantity because in mass we are only talking about the quantity or the magnitude of a body or magnitude of matter. We are not like taking any specific direction in the quantity of the mass. But in weight, it is related to the gravitational field. So according to the gravitational field, the direction is always towards the center of the earth. So,
Assalamu alaikum, sir.
Walaikum salam. It is a vector quantity. So this is the difference between the mass and weight. Mass is the quantity of a matter in a body, and weight is the effect of gravitational field on mass. And mass represented by the unit kg, and weight represented by the unit Newton. And one more important difference, mass remains same everywhere. And if we talk about the weight, so it depends upon the gravitational force of the planet changes from planet to planet. So this is the difference between mass and weight. And further, in the category of the mass, if we further define the mass, so mass can also be defined as the measurement of inertia in the body. So in the category of the mass, we can say it is also defined as the measurement of inertia. Is called mass. And what is the concept of the inertia? Because in definition, we only mention measurement of inertia is called mass. But if we talk about the detail of inertia, like what is inertia and how it depends upon the mass. So basically, before writing down the definition, if you consider, normally when we are like moving or when we are traveling in a car, let's suppose, so when we apply brake, so in which direction our body first moves, in forward or in backward? When we are traveling in a car, and when car applies the brake, so in which direction our body moves? In forward direction or in backward direction? So basically, when we apply a brake in the car, so body moves in forward direction. And when we start the car, so because of acceleration, body moves in backward direction. So this is because of inertia, because our body wants to remains in the same state, just like before. For example, initially when we start the car, so we are in rest state. So when car starts to move in forward direction, so our body wants to stay in the same position as before. So that's why our body pushes back in backward direction. But when we apply brake, So before applying the brake, car is moving in forward direction. So when we apply brake, so our body wants to move in the same direction, in the forward direction. So that's why body moves in forward direction after the application of the brake. So in detail, if we define inertia, so inertia can be defined as it is a tendency of a body to resist sudden changes in the state of rest or motion. So basically, it is the property of a body. So it actually resists the sudden changes. Sudden changes, just like we discussed when we start the car and car starts to accelerate. So our body moves in backward direction because initially body is in rest state. And when we apply brakes, so body is like in moving state, in motion state with the car. So when we apply brakes, so definitely body moves in forward direction after the application of the brake and then comes to in rest state. So inertia depends upon mass. It means the greater the mass, the larger would be the inertia. So this is the idea of inertia and the difference between the concept of mass and weight. And one more thing, we used to measure mass with the help of electronic balance and beam balance. So basically, it can be measured by electronic balance and beam balance. So this is the concept of the mass. And in the case of the weight, because weight is due to the gravitational force of the planet, so it cannot be measured with the help of electronic mass or beam balance. And if we talk about gravitational field, just like we mentioned in the definition, effect of gravitational field. So let's discuss about gravitational field also. So gravitational field is a region in space around a mass where another mass experiences gravitational force. So this is the concept of gravitational field. So basically, just like in our planet, we know when we try to jump, so because of the gravitational force, we come back towards the Earth's surface. In the same way, if we travel away from the Earth surface, so definitely after reaching a certain point, the gravitational force of the Earth will be zero. So according to the definition, we can easily identify it is a region in space. Space means like a blank space. So it is a region in the surrounding of Earth or any other planet where the body experiences the gravitational force. So in our Earth atmosphere, we also know that when you throw a ball to a certain height also, so ball also experiences gravitational force and comes back to the Earth's surface. That's why we know we use rocket and airplane with very powerful engines to take a body away from the gravitational pull of the Earth, right? So this is the concept of gravitational field. And further, there is a formula that is related to the gravitational field strength. So according to the concept of gravitational field strength, it is the force per unit mass at a point in gravitational field. So this is the idea of gravitational field strength. And we can also use the formula to calculate this gravitational field strength. And formula is equals to W over M. So W is the weight of the body and weight is also equals to the force. So if force is given, weight is given, we can use that value as the force, and M actually represents the mass of the body. So that mass is equals to the given mass of the body, or let's suppose in some questions we can also find out the mass or the weight with the help of this formula, right? So we can use this formula to calculate unknown quantity, just like mass, weight, or the gravitational field strength, whatever the quantity is missing in the question. So we can use this formula to find out that unknown quantity. So this is the difference between mass and weight. And one more difference, just like we use electronic balance and beam balance to measure the mass. So to measure the weight, we are going to use the Newton meter. So basically Newton meter gives you the value in newtons, because weight can be measured in the unit of Newton. So that's why we have to use Newton meter. Newton meter. Newton meter is like a scale with a spring attached in it, so you can easily hang anything with it. And when you hang, so definitely gravitational force pulls that body in downward direction, and because of that pull, we got value in the newtons. So this is the difference between mass and weight. And after the concept of mass and weight, we have one more quantity in this chapter, that is called density. So basically, for the concept of density, like if you drop a stone on the water surface, so what happens with the stone? When we drop a stone on the water surface, so stone sinks or it floats,
Since
right? So basically, when we drop a stone or a stone type material on the water surface, so that material starts to sink into the water. But if we observe the example of ships, or like a large heavy ships moving or traveling in the water or in the sea, so they are not actually sinking like the example of the stone. They can easily float on the water, and they are traveling easily from one point to another point on the water surface. So basically, how that heavy body, heavy masses are actually traveling on the water surface, but that mass of a stone, that is very negligible as compared to the mass of that heavy ship, but that sinks into the water. So this idea can be explained with the help of density. So the concept of density is mass acting, or in simple words, we can say mass per unit volume. So this is the simple definition of the density, and you can also use this definition in exams. And it tells about compactness of matter in a given volume. So basically, just like we discussed the structure, the concept of the stone, because in a stone, particles are very tightly packed, and there is no gap, there is no space between the particles in a stone. So more mass is concentrated in a small volume, right? So there are many particles, they are like contained in limited volume. So that's why the density of the stone is greater. But in the example of the ship, we observe that so many areas, so many region in the ship are completely empty. Just like if we consider the deck of the ship, So the deck of the ship is not always full, it is empty. It depends upon the passenger, if passengers are moving over there or they are sitting or standing over there. Otherwise, that deck is empty, and most of the region, most of the area in the ship is empty. And also, you observe that the size or the volume of that ship is also greater as compared to the mass and volume of the stone. So that's why a ship is able to float, because volume is greater and the mass concentrated in that volume is less. But a stone volume is small, and according to that volume, so much mass is concentrated in that limited volume. So that's why a stone becomes like uh, more dense as compared to the ship, right? For example, if we take a 500 ml bottle, or if you take any container with 500 ml or any specific capacity. So let's suppose in 500 ml water bottle, one bottle is filled with water, completely 500 ml, and the second bottle is filled with cotton. So we fill cotton in it, and the third one is filled with marble. So we have three bottles. Three bottles have same capacity, 500 ml, 500 ml, 500 ml, and in each 500 ml bottle we filled with different type of matter. In the first bottle we fill water, in the second we used to fill with the cotton, and the third one is filled with the stone. So which bottle you think will be the heavy one? The bottle that is filled with the water, for example, we have 500 ml bottle, and in one we are going to use for water. So one 500 ml bottle filled with water, and second is filled with a cotton, and the third one is filled with marbles. So, which bottle you think is the heavier?
Marbles?
Marble one. Because marbles, when we fill marbles in 500 ml bottle, so that bottle will be the heaviest one among all these three, because marbles are made up of solid material and they are tightly packed because they have fixed shape, fixed volume. But if we consider cotton, so cotton is like very soft material, and there is no particular shape. We can like make any specific shape, we can mold into any specific type of shape, so that's why it is light material. And if we consider water, so water is like a liquid, definitely it is not solid, or they are not tightly packed just like the solid material. So in the same way we are using, like in this example we are using same volume 500 ml, but we have different concentration of the masses. So that's why we have different density also. So the density of the marble bottle is the greatest one. So according to the formula, we can also compare density very easily. And the formula is density is equals to mass upon volume. So according to this formula, if we increase the volume, in this formula we can compare, if we increase the volume, let's suppose density decreases. And the second factor is density increases with the increase in the mass of a body, right? So first factor is density increases with increase in the mass. So mass and density both are directly proportional according to the formula, and the second quantity is volume. Density decreases with increase in volume, right? So this is the difference between the factors related to the density. So now if you again compare the example of ship and a stone, so the volume of the ship is very much greater as compared to the stone. So that's why ship can easily float because of less density. But stone sinks into the water because of greater density. So this is the difference between different densities of the bodies. And for the SI unit, SI unit will be equals to kg. For mass, we use kg, and for volume, we use meter cube. So kg per meter cube is the SI unit of density. So this is the basic idea of density, mass, and weight. And let's suppose if we consider some basic questions from mass, weight, and density, because in density we also need to study like how to find out the density of irregular objects. Just like if you pick any random stone, so definitely the shape of that stone is irregular. So if we want to find out density of that stone, so how we can find? So these are all ideas that we need to discuss. But before that, if we just practice the journal questions, mass, weight, and density. So in this question, you can easily compare the diagram of Newton meter and beam balance. So the first question, a brick is placed on a Newton meter and then on a beam balance. So you can see brick is first shown in the diagram of Newton meter and then in the diagram of beam balance. So which quantity we are measuring up with the Newton meter and with the beam balance? So with the help of a Newton meter, we discuss in the difference. We use Newton meter to measure the weight of a body. So with the help of Newton meter, we can measure weight. And with the beam balance, we can measure the mass. So option C is the right answer. Okay. Question number two, which property of a body resists change from a state of rest or motion? So we discussed about inertia, and inertia depends upon the mass. So basically, with the help of the mass of a body, the motion or the state of a body can be resist. Okay.
Sir, what was the answer again?
The mass of a body, because if the mass of the body is greater, so definitely it is difficult to push that body, and if the mass is less, so it can be easily pushed from that specific point. So mass is the factor actually that resists the state of rest or motion of a body.
Okay, sir.
Because if we consider a heavy truck that is like a traveling on a road, so definitely mass is very much greater as compared to normal car. So if that truck driver needs to apply brakes, so that truck driver applies brakes slowly because he knows that the mass of truck is very heavy. So if he suddenly applies the brakes, so definitely it will unbalance and there is a chance of accident because of heavy mass over there. So that's why if we are using a bodies with very heavy mass, so we need to change state slowly. Otherwise, there will be a chance of getting unbalance from the original state. And question number three is also just like the same, but question is slightly different. The mass of a stone is found on Earth using a Penn balance. So Penn balance shown in the diagram, just like it is a beam balance, and the weight of the stone is found with the help of a Newton meter. And right now we are talking about the Earth planet. And for example, are these readings the same or different on the moon? So if we measure the same readings on the moon surface, so what do you think about the mass and weight? Which quantity remains same or which quantity will be different? So which quantity remains same?
Mass?
Mass remains same. So mass remains same because in the difference we also mention that it stays same everywhere. But weight changes from planet to planet because it depends upon the gravity. So that's why mass remains same and reading on Newton meter will be different. The table shows the weights and masses of four objects on different planets. On which planet is the gravitational field strength the largest? So gravitational field strength means the value of G. And for this value of G, we discuss formula gravitational field strength G is equals to W upon M. So we can use this formula W upon M to find out the gravitational field strength. So one by one calculate in each option that in which option you are getting the greatest value.
Sir, I think it's option D.
Okay. So in the first option, we need to divide 2 by 20 because weight is 2 and mass is 20 and answer is equals to 0.1. And in second option, 4 divided by 30, it is equals to 0.13. Third option, it is equals to 0.15. And finally, 8 divided by 50 is equals to 0.16. So D is the answer. Unit is Newton per kg. So D is the correct answer. So this topic is very easy as compared to the other because questions are very straightforward. Question number 6. Which statement about mass is correct? So different statements are given. So try to identify which one is correct for the mass of a body. Okay, so according to first option, mass is density divided by volume. This is not correct. And according to C option, mass is weight multiplied by gravitational field strength. This is also not correct because we know that correct formula is mass upon volume, m into g.
Sir, is it correct? Option D.
Mass resists a change in motion. And in option B, it is mentioned mass is the amount of space. Basically, this is the definition of matter. Matter is the amount of space occupied by a body. So this
Yes,
definition
sir.
is for matter. So that's why option D is correct because it resists a change in motion. Right? So this is the correct option for question number 6. So in the same way, from this worksheet, you can practice the other questions from mass, weight, and density. Page number from 89 onwards. This is page number 89. So from 89 onwards, you can practice the other MCQ question related to mass, weight, and density. And this file is uploaded on the drive link. That drive link is also available in the WhatsApp group description. So you can access that link. So always you will get updated files, updated notes and worksheets. So from there, from the final term folder, you can download these files and the notes. And it will also be available on the LMS. So from LMS, you can also download from there, right? And next time, we will start with the concept of how to find out the density of irregular objects, right?
Okay, sir.